Hello. So, in this video, we are going to turn to a seemingly totally unrelated topic, in particular, areas of shapes. So, we have sort of a number of formulas for relatively nice geometric shapes. So we have formulas for rectangles, triangles, a bunch of regular polygons and things. But what about arbitrarily shaped, or arbitrary shapes that sort of have curved edges, right? Like, we know some for really nice curved things, like circles and sort of maybe some ovals or stretched circles, really. But that's about it, right? Like, anything else with a curved edge, we're like, that seems too hard. So here, our goal, we sort of aim to give, as a starting point, an intuitive argument, a geometric argument, on how we can calculate the area of a shape with a curved side, or at least estimate that area, okay? Way back in geometry, we learned formulas to calculate the areas of basic shapes, like rectangles are length times width. And then we split the rectangle diagonally to see that the area of a triangle is half of that. We then moved on to more complex objects by essentially carving them up into triangles to determine geometric and algebraic properties, like area, number of interior degrees, and the perimeter. But there was really only one or two objects with curves in all of geometry whose areas were even considered. And those were circles and possibly ovals, which are really just elongated circles. So despite all that time and effort spent in geometry, you never really discussed how to find the area of objects with curves, like this. Fortunately, we don't really have any tools to tackle this directly, at least not now. But sometimes we don't need exact values. Sometimes just an estimate is enough. So how do we estimate the area of this shape? We could start by doing the stupid thing. I mean, pretend this is really a shape we know. What if we estimate the area by pretending this thing is a rectangle? Then we would need the width and height to get the area. Okay, so clearly this is a pretty bad estimate. We can see that we have included way too much area. But at least rectangles are easy to calculate the area of. We could try another shape, like triangles, or circles, or octagons. But that would involve way harder computations. So instead, let's just stick with rectangles. Okay, so how do we improve our estimate? Well, we could try lowering the height of the estimating rectangle so that there's some area inside the rectangle that shouldn't be there, but also some area outside the rectangle which should have been in there, which might be closer to the real value. But how do we tell where the best height might be? This is actually a pretty difficult question to answer. And indeed, there is a way to do this, but it is way harder than it seems, and there is a much easier way to do something like this for this curve. So we're going to do that instead. Instead of trying to change the height or width of the one rectangle, we want instead to add more rectangles. You can think of this like pixels on a screen. The more of them you have, the smaller they are, and the better picture or the better estimate you get. So let's see what it would be like with 3 rectangles instead of just 1. We can see that by increasing the number of rectangles, we got a finer estimate, meaning that the more rectangles we used, the more accurate the estimate. Indeed, if we keep going and have more rectangles, let's see what happens. We'll need to be pretty careful on how we record this process, but remember that we chose rectangles because the formula for their area is pretty straightforward. So finding the area of any given estimate is simply a matter of adding up the areas of all the rectangles. And each area formula is just simply length times width. Although the calculation may be long and it can get a bit tedious, it isn't exactly difficult, at least in principle. Already, you should have an intuition as to what will end up being the key analytic tool we'll need, but we'll get to that in another segment. Okay, So we've seen that we can get approximations for areas that have curved edges, at least, by using these rectangles, right? We sort of spread these rectangles throughout the region and use the sort of easy rectangular area formulas. Add all those things together, we can at least get an approximation of what that area should be. Okay, so this is something to keep in mind moving forward. We're going to use this idea and then, as is sort of almost always the case, sort of refine it into something that is progressively more useful. Okay, so that's that.